we will go to discuss about that properties of fluid. That is, any characteristics of the system is called a property. Some familiar properties are pressure, temperature, volume, and mass. Okay. Other less familiar properties include viscosity, thermal conductivity, modulus of elasticity, thermal expansion, electric resistivity, and even velocity. They are either the properties are considered to be either intrinsic properties and extrinsic properties. The intrinsic properties are those who are independent of the mass of the system, such as temperature, pressure, and density. The extrinsic properties, those whose values depend on the size or extent of the system, the total volume, total momentum are the sum of the examples of the extensive properties. The properties of fluid, here we will go to discuss about that density or mass density, specific weight or weight density, specific volume, specific gravity, and viscosity. Density or mass density. The density or mass density is defined as the ratio of mass of the fluid to its volume. Thus, the mass per unit volume of the fluid is called density. It is denoted as rho. The unit of the mass density is in SI unit kg per meter cube. In formula, the rho is equal to mass of fluid to volume of fluid. The density of water is 1000 kg per meter cube. Next, we will and the density of the liquid may be considered as a constant, while that of the gases changes with variation of pressure and temperature. So, the density of the liquid constant. In general, density of the substance depends upon the temperature and pressure. The density of the most of the gases is proportional to the pressure and solid to the proportional to the temperature. The solids essential, that is, and variation with the pressure is negligible. Next, we will go to discuss about that specific weight or weight density. It is denoted as small w. It is ratio between the weight of the fluid its volume. Thus, the weight per unit volume of the fluid is called as weight density. So, small w is equal to weight and mass. Normally, weight of the fluid is equal to mass of the fluid into acceleration due to gravity divided by volume. So, small w is equal to rho into g. Next, specific volume. The specific volume of the fluid is denoted as defined as volume of fluid occupied by unit mass or volume per unit mass of the fluid is called specific volume. It is expressed as meter cube per kg, and also specific volume is called as reciprocal of mass density. It is normally applied to gases. Next, we will go to discuss about the specific gravity. The specific gravity is defined as the ratio of the weight density of the fluid to weight density of standard fluid. For liquid, the standard fluid is taken as water. For gas, the standard fluid is taken as air. The specific gravity also denoted as, also called as relative density. It is denoted as S. It is dimensionless quantity. Next, specific gravity. We will go to discuss about that specific, that is gravity in the weight density of the liquid is equal to S into weight density of the gravity. In this way, we have to find the density of the unknown liquid. Density of the unknown liquid, that is specific gravity of the fluid into density of the standard fluid. For example, liquid, the density of the standard fluid is 1000, that is density of the water. For example, the specific gravity of the mercury is 13.6. The density of the mercury is 13.6 into 1000, 30,600 kg per meter cube. Next, we will go to solve this problem. From that problem, we can learn about the relationship between the properties. Okay, that calculate the specific weight, density and specific gravity of the 1 liter of liquid which weight is 7 Newton. So volume is equal to 1 liter, that is 1000 1 into 10 to the power of minus 3. Weight is equal to 7 Newton. The specific weight, that is equal to weight by volume, we have to find that 7000 Newton per meter cube, and we have to calculate the density of the particular fluid. Density is equal to mass by volume. Here weight density, we have already calculated the specific weight, that is small w is equal to rho into g. We need to find the rho, that is density. Rho is equal to small w by g. So in this way we can calculate the 713.5 kg per meter cube. Density also calculated. Next we will to calculate the specific gravity. Already we know that specific gravity S equal to the ratio between the density of the liquid to density of the water. From that we can find the specific gravity. From already I told that from that problem we have to find the or understand the relationship between the properties of the fluid. Next problem we will go discuss about that. Again we calculate the specific weight and specific mass, specific volume and specific gravity of the liquid having a volume of 6 meter cube and weight. Volume and weight is given. In from that we can find the specific volume and mass density and to the specific gravity. Okay, same way we have to calculate the density and specific weight of the 1 liter petrol of the gravity. So in the all the three problems are well, we have to practice the formulas and also relationship between the, already we told that the relationship between the various properties.